In Haskell, when we want to define new data types, we have two different possible ways of doing so. Here, I have four example data types, which have been defined in the usual default style. I have a copy of maybe, a copy of either, a data type with a phantom type parameter, and a record. So nothing particularly surprising. And now I'm going to define these data types using the alternative syntax, which is called GADTSyntax, and is enabled by this extension. And this extension is also included in the GHC 2024 set of extensions, of commonly used extensions. So perhaps you may want to enable GHC 2024 instead. So the normal way of defining data types kind of loosely resembles how values of that data type are pattern match. But the JDT way of defining data types instead resembles a list of signatures for the data type constructors. What do I mean? So I'm going to list the type of nothing here. Okay. And I'm going to put it in a comment. I'm going to do the same with the type of the my just constructor. Okay. And I'm going to put it in a comment as well. And now I'm going to switch to GADTSyntax. So instead of the equal sign, we put a where. So this is in a way more consistent with how class instances are defined. But so we put a where instead of the equals, and we list the constructors, okay, with their corresponding signatures. And this is GADTSyntax, basically. And well, I'm going to do exactly the same with either. Okay. Okay. And again, I'm going to change the equal sign into a where, and I'm going to list the constructors. Okay, so this is an either like type defined using GADTSyntax. And exactly the same with this type. Okay, so here we are getting like a generalized version of the constructor, which is polymorphic on the kind of the phantom type. Maybe we can. But maybe we don't need that much generality, so we can leave it at here. Okay. And for records, it's perhaps a bit different because when we hear we see the parameters are displayed using positional parameters, but the constructor, the GADT constructor here, can be named as well. So it's a bit different as the previous examples, but not that different. So what I mean is that I can still do that Okay. Okay, this is the syntax for defining a record in GADT syntax. So you may ask yourself, why have two different syntaxes for defining data types? Well, the reason to have GADT syntax is that there are some types which are a bit more sophisticated, for which that we can define in the usual default syntax, but that we can define in GADT syntax. So those types are GADTs, of course, but also it gives us more control when working with linear types and other extensions. So this is the motive for having GADT syntax. And this syntax resembles more how data types are uh, defined in languages with like Idris and Akda and theorem provers like Ling. So in this sense, uh, it will resemble the data type definition in other languages as well. And so in this video, I'm not going to go into give examples of those more sophisticated data types for which GADT syntax is necessary, but maybe I will do it in a later video. And this is all. Bye.